All right, thank you for tuning in. Today I want to talk to you about real-world Docker images for .NET applications. My name is Thorsten Hans. I work as a cloud-native consultant with Thinktecture here in Germany, and I mainly focus on cloud-native and containerization. So the most important thing on this slide is obviously my mail address. So if you have any question, don't hesitate, just ask or use the platform that you use for streaming the event. Without further ado, let's jump right into the talk. So in the upcoming 30 minutes, we will take a look at different aspects that you should take care about when building Docker images. Although this talk is focusing on .NET applications that we containerize, I bet that you will find some useful information that you could also take into consideration when building Docker images for other programming languages. So let's jump right into the introduction, right? So as I said, there are different requirements that you may want to address when building Docker images. And typically those requirements are brought to the table from different people, right? So the people that are responsible for running our container images, let's say in production, they obviously want robust and secured Docker images. So that's one thing, and it should always be top on your mind when building Docker images, that you scan those, that you try to fix vulnerabilities, then you check all the materials, so the software bill of materials, to see, okay, what's inside of my Docker images and do I need all of those components. So building robust and secure Docker images is one requirement. But if you are a developer like me, then there are other requirements that you have when you think about great Docker images, right? So you obviously want to debug with ease, which means it should not be a big difference if you try to debug your .NET application locally or if it runs inside of a container, right? So that's one thing we will take a look at. And last but not least, we will take a look at how to build Docker images that helps you being productive, right? So that address the inner loop experience. Typically, you may want to take all those or address all those requirements within a single Docker file. However, for the sake of this talk, we will create individual Docker files for every scenario. So let's jump right into building production-grade Docker images for the .NET applications. The good thing, we do not have to start from scratch over here. So I have Visual Studio Code installed on my machine, and I use the official Docker extension that's provided by Microsoft that we can ask to, generate a Docker file for us. And from that Docker file, we will start, optimizing it. So there's some plumbing that we could get rid of. We could streamline the process of building and publishing .NET application inside of the Docker image. And last but not least, we will address a very common pitfall that you may hit when running your .NET application inside of a container. All right, that said, let's jump right into VS Code. And I have a demo application over here. It's, just let me get rid of the Docker ignore file. So it's the Hello World example, right? I just removed the weather forecast controller and introduced the demo controller over here. So there's a get endpoint that is just echoing Hello World, and there is a post endpoint that we can send any kind of message to, and the API takes this message and writes it to a file. And the file will resist in the out folder, which is a subfolder of the actual application or of the compiled and published application later inside of the container. So that's all. It's not about .NET or writing .NET APIs today. It's more about containerizing it. And as you can see, I have the nice Docker image over here, which means I have the Docker extension installed. And with that, I could use the command palette from VS Code and add new Docker files to my workspace. So let's do that. And yep, we are talking about ASP.NET Core over here. Obviously, we want a Linux container, and we want to expose our API on port 5000. That's correct. The wizard also asks if we want some Docker Compose file. For now, let's just skip that. So no, we don't need that. And no, we don't want to update the task file. So we get, quite good, let's say that way, Docker file generated by the extension. So we have a multi-stage Docker file that takes ASP.NET Core as a base, and then we get some configuration about exposing our application, specifying the URLs that ASP.NET Core will pick up and run the application on. Then we create a non-privileged user over here, which is a good thing. So we do not want our app to be invoked or run as a root user. We immediately impersonate into that user. And then right here in line 12, we introduce a new base. So we start with the .NET SDK and we give that, stage an alias of build. Then we copy over all, first the project file, then we restore the dependencies, then we copy over everything else in line 16, and then we build our application for the release in the release configuration. Once the build has done, then we publish the application again in a release configuration to app/publish. And finally, we start on a clean surface, so from the base. So remember, we are impersonated as the app user. Our port or our API is already configured to be exposed on port 5000. And then we copy over the published app into the app folder on the clean container image, right? And last but not least, we invoke .NET to run our API. Looks pretty good. However, we can optimize it. So we have several stages over here, right? We have the build stage, we have the publish stage, and we are invoking .NET Restore, .NET Build, and .NET Publish. Sounds good. However, we can instruct, or we can, combine some of those commands. So for example, if you run .NET Build and .NET Publish, right, in that order, then you will end up and build your application twice. So because publish will always build your application if you don't explicitly ask it to not build your application. So we can, get rid of, let's say, the build. We can get rid of the build command, and we could get rid of the publish stage. And in line 15, we are already restoring all dependencies. However, .NET Publish will restore also all dependencies. And we can again optimize that by saying no-restore over here. All right, so let's call our image again publish, not build, so that everything beneath, works as expected. Alrighty, so right now we have, streamlined the .NET compilation and the publish process a bit to save some seconds when building the image. Let's quickly review everything. Okay, looks good. With that, we can just, say docker build in the current folder and tag the image as test. So our image has been built. We can give it a shot, right? So we can say docker run as a daemon, and we want to map the port 8080 from my host system onto port 5000 of the container, and obviously create the new container from the test image. There we go. So we can check for logs, Docker logs of fd, and as you can see, our app over here is running on port 5000. So let's give it a try. So from the host port 8080, we forward traffic to port 5000 of the container. Let's invoke the echo endpoint, and let's see what we get back. We get back a HTTP 200 with hello world. All right. Now let's try to invoke the write endpoint so that we get a new file in the container with the message hello community all hands. Let's invoke that one, and boom, we got a HTTP 500. So what happened? Let's check. Let's say Docker logs again, and as you can see, we get plenty of log messages, and over there we get system unauthorized access exception, access to path app out, yada yada, some file name is denied. Why is that? So let's clean the terminal, and let's exec interactive tty into our container with identifier fd, and let's do a bin bash over here, and let's do a lsla. And as you can see, although we impersonate in the early stage, the publish command is invoked as root. And so root is right now owner of the out folder where we try to write a file into. And that won't work because who am I? I am app user, and I'm not authorized to do that. All right, so let's go there and let's say docker rmf, what was it, fd. Let's kill the image. There we go. Let's kill the container, sorry. All right, and let's address that pitfall, right? So let's get rid of this, and let's get rid of this and this. There we go. We can simply, change the ownership of the out folder, or we can change the ownership of everything that has been published or has been created by the publish command upon or during the copy operation. And that's also a best practice, right? Because if you use, for example, let's say run, and then let's say chown app user on /app with recursive and so on and so forth, this will result in another layer being generated. Instead, we can do that in place and say chown as an argument, or we can provide chown as an argument for the copy operation, and let's say during the copy operation, please change the ownership of everything that you copy to the app user. All right, so with that in place, let's build our image again. Let's say docker build. Now we should see a bunch of operations cached. There we have a new test image, and let's say docker run again, use the port forwarding. Then we can open up our test file. Let's again test the echo endpoint, and we get back an HTTP 200. Let's try to write the file, and we see, okay, we got back a 200, and the content should be written to a file with the name w2 and so on and so forth. So let's check this. Let's say docker exec interactive tty in d2, and let's say bin bash. Let's go to the out folder, and let's clean the terminal, and let's do a cat on w2, and we see hello community all hands. All right, great. So let's docker rm d2, and let's move back to PowerPoint. So with that, we have taken the default Docker file that is generated by the Docker extension in VS Code and optimized it a bit, right? We removed some of the stages, we streamlined the build and publish process, and we addressed one of the most common pitfalls when relying on that, default or let's say generated Docker file. Great. So next is remote debugging. So Microsoft provides a remote debugger that developers can use from any kind of platform, on Windows or Mac or Linux, to attach to a .NET application. And tools like Visual Studio on Windows, on Mac, or VS Code, they can connect your IDE or your editor in a debugging session to the application being executed somewhere. Somewhere in our case is obviously inside of a container. So the Docker extension for VS Code allows you to attach to a .NET application that's running inside of a Docker container. And what they do, as soon as you hit that button, right, they do a Docker exec and they install, the remote debugger into the running container, and then they can attach VS Code to your application. However, this is great, right? However, it's terribly slow because it, means downloading everything on demand, right? In that second, when you actually want to debug your application, you want to do troubleshooting, you first have to wait for, the remote debugger being downloaded and so on and so forth. Instead, what I recommend is baking the remote debugger into a debug image, or baking it into an image and use a build argument to specify if you now want to build a container image for debug or for release mode. And so that's why it's important, to align that existence of the remote debugger with your tagging strategy or policies, right? All right, again, let's jump right into VS Code. And for now, as a starting point, we will take the Docker file. Let me quickly clean up the surface over here a bit. So we take the Docker file and just create a copy of it and name it right now debug Docker file. All right, so we have, let's check what we have. We have the workday over here. And we have set this one, that's great. So let's have a snippet, let's say download .NET Debugger. So there's, the VS remote debugger that's available via a short link, and that's written in documentation, or everything's described in documentation provided by Microsoft, how you can download or where you can find everything. So let's take it as it is for now. And as you can see, we changed the remote, the workday to remote debugger, because that's also the path where VS Code Docker extension installs the remote debugger too. And if you use the same folder as a destination, then VS Code won't try to install it on its own again, right? So with that, you can just take your image and hit the attach to .NET Core in a container button in VS Code, and it will seamlessly work. However, we have to also show the ownership for that folder over here. Then we impersonate into the app user, and then we have to install the .NET Debugger. And as you can see, again, we pointed as a location to the remote debugger. With that, let me quickly check. We want, obviously not release, we want debug mode in our case. And then we take base app, change that looks good. Okay, so let's build this Docker image again, Docker build in the current folder. However, we want debug.docker file, and we want to use debug as a name for our new image. All right, so with our debug image in place, we can just say docker run. Again, let's use port 8080, forward it to port 5000, but right now let's use the debug image. Let's check the logs again, logs for 9.2. And as you can see, we're again running on port 5000. So let's say we want to debug the hello world endpoint, and we use docker.net attached. This is also configuration that I will post a link to the repository in the chat. So no worries, you get everything you need to, rebuild all those things on your own machine. So let's say start debugging, and now we select to which container, tender shaw, that's how it's called. Now we should see the debug console in a second. Is it already attached? No, it's still in the process of attaching. Right now it's loading the symbols. And we can also already move on to the HTTP file over here. And let's check the still loading symbols. Come on. There we go. So let's just invoke our hello endpoint. And we should see VS Code jumping right into our API. There we go. So right now you see that we have access to everything that we need. So for example, right here I have a watch. I created a watch for the request method. So we have all the debugging capabilities that the IDE offers, right? We can expect locals, we can see the call stack and so on and so forth. And we can easily debug through our .NET application, although it runs inside a container. Great, so let's disconnect the debugger and let's again clean up by docker rm92. There we go. And let's do a KW, move over here and jump back to the slides. So last but not least is the inner loop performance, right? How can we as developers stay as productive as we want it to be when developing .NET applications inside of Docker images or in Docker images to run them in Docker containers, right? So obviously it heavily depends on the tooling that your programming language offers. However, so all the languages I use, there are typically tools that you can use to, get something that's called hot reload. So if you do a change in a source file, the executable immediately catches up those changes and, restarts your application, or either, changes the parts of the application that you changed in the source code. And for .NET applications, this is .NET Watch. However, .NET Watch, so the .NET team differs edits that we make in the source code. So there are regular edits that they can easily, recompile the source and change it on the fly without restarting the process. And there are so-called root edits. Root edits are, edits that you as a user do that, have the requirement of restarting the application. Typically .NET Watch will ask you, hey, there was a root edit, do you really want to restart the application? However, you can, get rid of that confirmation by setting that environment variable over here to true in order to restart the process automatically. So let's build our inner loop Docker file, right? Jump back to VS Code and let's say inner loop .docker file. So this Docker file is very different from the others we saw so far. So that's why we start on a clean surface and just take those, let's say, commands or expressions that we want to use over here. Let me quickly check. We want obviously this one. There we go, and we want to impersonate into that user. That's also true. And we want to use this one. We will clean it up in a second. Then we want to set the variable that I mentioned. So this one, and depending if you want to, use HTTPS inside of the container or not. Typically, I, see configuring HTTPS in the responsibility of the surrounding infrastructure or orchestrator, aka Kubernetes. But yeah, so with that, we get the developer certificates from .NET CLI inside of the container. So let's revisit what we have over here. So we have the .NET SDK as a foundation, right? We set a work to source. We say we want to expose port 5000 and also instruct ASP.NET Core to use or to run the API on that port. Then we create our non-privileged user again, impersonate into that user. We change the ownership of, obviously, of source and all of that. Then we set the environment variable. We can move that over here. And then we do this and we run .NET Watch. All right, that's it. So let's build the image. And let's call the image inner loop. There we go. And we should be done in a second. Come on. There we are. Okay, so let's say Docker run DP. Let's use the port forwarding as we did. Then we configure a volume and we want to use the current working directory, which is the source folder, and mount that in our container at src, and we want to use the inner loop image. Let's give it a try and let's check for logs. 6.8, and let's follow the log because it's still building right now. It's restoring the dependencies, so this will take a few seconds, right? There we are. So the app is right now running in the container on port 5000. It's watching for changes. So let's take the HTTP file over here and let's send a request to the endpoint. We get hello world back. Right now, let's go to the demo controller and let's change the response to community all hands, and let's save the file. And we immediately see in the terminal that .NET Watch recognizes the file change, picks it up and reloaded the changes. Let's go over here, send a request again, and boom, there we have it. Hot reload for your .NET applications while running inside of a Docker container. And with that, let's move back to the slides and bring this to the end, right? So what we've seen, we've taken the out-of-the-box Docker files generated by Microsoft's Docker extension for VS Code and optimized them a bit to address some, performance aspects and get rid of some pitfalls that you may run into. Then in the second example, we have installed the remote debugging capabilities for Visual Studio and Visual Studio Code into our Docker image. And last but not least, we've created a dedicated image to address inner loop performance considerations, right? So the key takeaways from my point of view are that you should identify and address all the requirements by all the personas in your team as early as possible. Maybe you will end up with one, little bit more flexible Docker file. Maybe you end up with 1 or 2 or 3 Docker files as we did during this talk. It doesn't matter. It's just, important is that you address those requirements. you should always, always optimize your Docker images as a developer to support you in being productive, in being as productive as possible as a developer, because that's what you do on a daily basis, right? And imagine, saving just a minute for attaching the debugger to your .NET application running in a Docker container, and then multiply that by, the times or that you debug on a daily basis, and again, do the math to calculate it up what you may save over the past of a year. But no matter what you do, no matter which requirements you address, always harden your Docker images and always check them for vulnerabilities. We have great tooling in place to address what's called shift left security, so that we as developers can also, take the responsibility to build secure and safe Docker images. And with that, I want to thank you for your attention. And if you have any further questions, don't hesitate, use the chat, shoot me a mail or tweet, and let's have a discussion about building Docker images for .NET applications. Thank you.